you see that?
Yes.
It's sharing, yeah?
Yeah.
Just trying to minimize the screen here on the left. Is there a box in the way of it?
No. And if you just want to go, yeah. One screen there, yeah.
Okay, so good morning, everyone. Alan Ledwith is my name. I'm founder of Terratonics. Originally, I set out moving away from concrete with my father back in the early 80s. He was one of the first implementers of using timber frame construction in Ireland. And I worked with my dad for a number of years. I've also set up my own construction business back in the early 2000. And back then, I was still eager to progress with timber frames, and I worked setting up our own manufacturing facility in Meath, and that went well up until the recession back in 2008 to 2009, when it started affecting everybody in the country. And so at that quiet time, I was just doing one-off houses and that in the meantime. And then as things progress, I tried to reinvent what I'm actually doing in the construction industry. And I noticed that even using timber frames and that, we're still using quite a lot of concrete, and the world is crying out for solutions to move away from concrete. So I focused a bit of time on that, and that's when I set up Terratonics. I suppose a lot of people in Ireland and around the world don't realise the amount of concrete that we use, first of all, and also the massive impact that it has on the environment. So we set out to try and remove concrete from one part of the construction that's been overlooked for a long time, and that's the foundations, especially with the likes of timber frame, like gauge steel or SIP type, which are structurally insulated panel type buildings that still use the same foundations as you would for traditional masonry house. So with our climate issues, we need to take action. As you can see here, the time is running out to take action with the CO2 emissions every year, having a record level increase in the year before. We got some funding there from Climate Kick a couple of years ago. We won the Climate Kick competition, which is a European Union driven climate incentive body that was run by Trinity College. We're supported by Enterprise Ireland. And we're also supported by the Irish Green Building Council. We're a labelled solution for the Solar Impulse, which is efficient solutions for Europe and for the world. If we look at concrete, I know everything here is about pyrite and mica, but also the huge damaging effects and the impact that concrete has on our planet is quite detrimental. We mightn't see too much of it in Ireland because our resources such as water and sand and gravel are quite in high stock here in this country. But in other countries, people are fighting over the rights for quarries. They're fighting over the water rights, and sand is depleting throughout the world. And every year, typically, we'd use 3.6 billion tons of water, 4.4 billion tons of gravel, or cement, sorry, 8.8 billion tons of sand, and 15 billion tons of gravel. And the sand that we use can't be wind-blown sand. It has to be derived from either quarries, from glacial deposits, from riverbeds, or from shores such as beach sand. And to put this into context, the global emissions of CO2 levels from concrete production equates to 10% of the total global emissions in the world. And it's twice that of all the global fires combined in the world every year. We empty the equivalent to Loch Ness every year, 3.6 cubic kilometers of water is used in the concrete industry every year. And we actually take away the equivalent to 25,000 Bondi beaches worth of sand every year. So you can see the impact of concrete is very substantial and it's not sustainable. So we look, is there a way we could do this without using concrete at all? And we turned our attention to what's out there already. And one thing that's out there already is the way we construct roads. Roads are a flexible type construction, but still very hard. And if done correctly, they can last for a long time and take a huge amount of abuse from dynamic loads. Our houses are getting lighter. So if we do a combination of using similar technology to engineer the ground for the construction of the underside of houses and the foundations, link that with a system that connects directly to the house, then we have a solution for the problem. If we look back through history, typically in seismic zones in Asia, the Japanese used a system I call Ishi-bate, and it was a system of timber beams sitting on stones. And the ground underneath these large stones you see here on the right-hand side, you see those? Hello?
Yeah, you can see that.
Sorry, it's all silence there. I'm just wondering without, is anyone hearing me? Yeah, well, underneath those stones is smaller stones, which is part of the foundation system. And it's all about directing the loads from the building above to the ground below. And it's also without a direct connection to horizontal movements that you would totally get from seismic activity. So these houses would have stood up in earthquake zones. And it's a traditional way of building that was got rid of by the Americans by their input of concrete into Japan after World War II. Most of Japan was actually burnt to the ground by firebombing during the war. So the rebuilding of Japan was all undertaken by the use of concrete for the foundations and floor systems. And so the solution is a Terrapod, which is a height adjustable pedestal beam carrier. And these are laid out in a grid system where the beams are all bolted onto the side flanges of the Terrapod here. And these beams then support the floor and the building above. The Terrapod itself is made out of Nyram, which is it's a heavy industrial new type of engineering polymer. It's extremely strong. We've load tested these individual Terrapods up to 40 tons without failure. In reality, to be using between, or to be loaded up to 2 to 4 tons each individually. We're also engineering new types of composite beams. This one here, for example, is using recycled reinforced glass as a stiffener between laminated timber. And this creates a really rigid, strong type beam system. You can see here where on the bottom left-hand side, where the Terrapods and ledgers of the beam support SIP panels, which are a highly insulated flooring system. And then here on the right-hand side, we can see that the whole lot comes together, sitting on stone. So typically the ground has to be engineered, and that's a site-specific type of engineering. So every site is different, as you know, and even and parts of sites can differ from one ground type to another. So the engineers would determine what sort of soil or ground buildup is required underneath the Terratonics type foundation system. And that's done locally. You can see here again a more exploded view. We can implement the use of geotextiles, geocells or geogrids to add extra stability and tension into the mechanical strength of the ground beneath the whole system. So it's done in different layers. So for example, here we have the subgrade soil. We have a geotextile. We have one layer of a crushed large size stone, say a 3-inch down to 4-inch down. And we can use cellular confinement cells if required. It's not necessary either. and then we finish off with a layer of 804, which is a smaller type crushed stone with binding sands between. Excuse me. The embodied energy then, comparison between concrete and between the Terratonic system here is a huge difference. And the reason for that is the amount of energy used in the cement portion of the concrete is colossal compared to what's used in the production of the pteropods. It's also that there's only a small amount of pteropods compared to the large amount of concrete that's used typically on a construction site. There's less deliveries to site, less materials used as well. And here's the CO2, a comparison between both as well. See, there's a huge discrepancy in the volumes of CO2 emitted from both. This was our first project that we done using the theropods and beam system, and that's where I'm from today. And so we're working with the likes of McDonald's, and we have projects coming up this year in Belgium, Spain, Morocco, and France. And the Europeans are very interested in using this system, and they're very excited moving away from concrete systems. So here's some of the key benefits from using the system. It's up to 10 times faster. There's no need for any curing of the concrete. There's up to 80 to 90% less emissions. There's no water required on site at all. So it's ideal for countries that in arid regions, because you don't need large trucks also carrying 8 cubic meters or 9 cubic meters of concrete in arid conditions. There's no restrictions on the movement of the pteropods through these regions, whereas it's very hard to pass the 60 kilometer or 70 kilometer distance from a manufacturing plant to site, as there's a danger that the concrete will actually set in the mixer itself or the delivery truck. And because we're not using concrete, we have no pyrite and mica issues. There's minimal flood displacement in flood zones. So typically the foundation system of a normal type structure adds to flood problems because it increases the volume. It displaces the water that's around it. So if you have a housing development where there's hundreds and hundreds of houses with all similar type foundations, it actually exacerbates the problem of flooding in those areas. There's an 80% reduction in site deliveries, simple to install, it's lightweight and ergonomic for the workers. And there's no back-breaking work such as putting down laying blocks and bending over all the time on site. There's an 80% reduction in site excavations and transport of waste materials from a site. It's not weather dependent, it's safer in seismic zones. There's no radon issues as the whole system is up off the ground and can be ventilated. The system won't be actually seen from outside. It'll be all covered off with inverted walls beneath the beams. There's a long lifespan on the whole system, as it will not corrode. So, for example, the pteropods themselves will have a lifespan of about 200 to 300 years. The typical lifespan of houses in some regions of the world, especially in Japan, is only about 40 to 50 years, and then they're redone again. So in locations like this, we could actually reuse the pteropods for second or third type pass. There's a long guarantee with the product, and it can be installed by semi-skilled labor or supervised labor. It's flexible and modular design, and it's easy to extend or easy to actually add on this type of structure with an MMC to your existing building as well. So you don't have to wheelbarrow concrete around the rear of a house. So that's it, everybody. Delighted to hear any questions from you.
That's amazing, Alan. It opens up fantastic possibilities there. Expense wise, I know maybe we'll go, we'll have maybe Q&A after yourself and Donal, like, so I'm sure there'll be a lot of questions coming in there, if that's okay. And are you being joined by Finbar as well a little bit later in?
Yeah, Finbar is going to come on and do the same thing again now in 10 minutes.
Not the same presentation though, no.
No, we're going to share that presentation between us.
Yeah.
That's okay. No, I'll let him know it's okay.
Yeah. But maybe if he wants to join the conversation, for sure.
Oh yeah, you do that. We can just say it when he comes on then.
Yeah. So Donal, are you good to go? I was talking to Trish there.
Yeah, I have my PowerPoint up here again. If we screen share.
Okay, let's go. We go through the two of them, but then we have a little bit more time for Q&A. I'm keeping an eye to see if any of the other companies have come in on the side, but so far no.
Okay. So do I just hit the screen share there now? Yeah.
Yeah.
Okay, share. Okay, can you see that?
Not yet, but it'll probably come up now in a minute. Oh, there we go. Brilliant. Yeah.
Perfect. My apologies. We don't have unbelievable internet access down here at the moment.
Joe's people said yesterday. So if you want to go through there, do you see there, Donal, over? I mean, we could go grand like that. So go forward, and that's no problem.
So my name is Donal Byrne. I'm the Managing Director of Big Red Barn Limited, or as it will be known in a few weeks, BRB Homes, Byrne Rapid Build. We started off, my background was construction, and I had been involved in the event industry, and I got a job in London as the operations manager for the Olympic Park during its construction phase. So we were testing a lot of venues, and I remained on during the Olympics. And one of the major problems we had was temporary structures, marquees, port cabins just weren't suitable. So when I came back to Ireland, I designed the Big Red Barn, which was a modular event structure. And then we started to do smaller houses, and now we do full plan inspect homes, A-grade homes. At the start, we outsourced engineering work, and now we do all that in-house. So when a customer comes to us, we apply for planning permission for them. We come in and do the groundworks, and then we build the house here in the factory. So what you're looking at there is an aerated 1,700 square foot dormer house, and it's in panelized construction. On the outside of that, you're looking at an external insulation and rendered finish. You also can see a timber clad here option. It's all steel frame. So I'll pop through a few pictures. We'll say of a house going up so you can try and understand it. So this is a bungalow house that we done a few weeks ago in County Mayo. And again, this is a panel here. Okay, so it's all lifted in, the windows are on it. It sits on galvanized legs that sit on a concrete foundation. Love to try and maybe have a look at those Terrapods. Was the first I'd heard of them, so it might be one that we could try and use. And generally we stand the house in about a day, and then we move on to the roofing the next day, internal fit outs. So really we're on site for a plan inspect house about 6 weeks, start to finish. We don't outsource anything, only the kitchens. So all the way the groundworks, we've started doing foundations in the last 3 years, because again, outsourcing that just slowed the process down. So we'd say that's that house now as it arrived on the truck. And then you can see they start to put it together panel by panel with teleporter. This is, we'll say, a finished product house. So at the moment, everything is made here in Swinford. We buy all our steel locally through Butlers. They're probably one of the biggest steel manufacturers, suppliers in the country. It's all CE certified. And the frames are welded. They then go in for carpentry, where there's fibre cement board if it's an external finish, or timber on the outside. They're loaded up on the trailer now. So we turn out about 2.5 houses a week. At the moment, we're crazy busy because the general cost of construction is just totally gone out of control. Let's take that for a moment and look at prices. General blocks of mortar at the moment in our area here is between 190 and 220 euros a square foot. We're at 147. So you have the guts of 50 euros per square foot. Ours is a full turnkey finish. So you can see here, this house we kitted out with all the furniture as well. We have a deal done with Harvey Norman and Cass Furniture. So a lot of our customers may be in America or Australia, and they just want to come home and walk into their house. So we hired the interior designer and we kitted out as well. So you can say, look, I have my own kitchen guy and I'd like to do my own kitchen, or I have my own carpet guy or whatever like that. That's not a problem. We can tailor the package to suit. Some people love the everything done for them. Some people prefer to have their own touch on it. We do some industrial work then as well. We see modular garages. We do an awful lot of work in the nuclear power plant in Hinkley Point in England. They had an awful lot of temporary warehousing and stuff like that. But I know you're not interested in that today. It's mainly houses. So we were approached by some of the people from Belmullet from the Pyrite scheme there, I suppose it would be 2.5, 3 years ago. And we got the first few across the line for planning permission about 2 months ago. And they're now waiting on the final redress before they make a decision on what they're doing. We know the stories and they're horrendous. And I've been down and seen the houses, and you know, unfortunately, it hasn't been dealt with great from top to finish, and a lot of them don't have the confidence in going back to general blocks and mortar build, which is understandable. So the people are saying, well, we want to come and replicate our house the way it was, or you know, we have designs of a house. What can we do? There's two things we try and stay clear of. One is valleys in roofs. So if you'd see, all the roofs are quite A-frame straight roofs. This is a 2-story we're doing in Cork, but you'll see again the roof has no valley in it. Which the reason we want to stay clear of valleys is we give a 25-year structural warranty. The biggest things that always give trouble in houses are leaking valleys. We use a full Kingspan roof, a 120mm panel, and then we put a slate effect over it. It guarantees that you're not going to have slates whipping off like you would in a storm, a leaking valley, stuff like that. So again, the outside there it's a fibre cement board that's on it. The external insulation goes off that. A line of soap bars go along the bottom here, so you won't see the void. So when the house is complete, there's no real way of telling that it's off the ground. If we take this one here, you can see it's rendered all the way to the ground. So this was the house before. We'll say the landscaping was done on that. What's our biggest seller, I suppose, is our dormer house. This one here. This was a house we put up at the National Ploughing Championships 2 or 3 years ago to show how fast a house could go up. And we haven't really done any advertisement since then. They sell themselves. If we do a house in an area, you can nearly be sure we're guaranteed to be back within 5 to 6 months. And we're trying to get out of Cork, I think, now for the last 3 years, and we haven't managed because one neighbour will see it and tell another one, and they'll be able to see how fast it was to build and how warm it is to run. So let's take the heating of it. The house is heated on a heat pump air to water system. Again, they're A-rated homes, so A2. Some people have gone with solar panels to bring it up to A1. I've spoken to customers and gone back to see how they are in relation to electricity bills. They're talking about 150 a month, so 300 every 2 months, and that's all your heating, hot water, cooking, because the whole thing is electrical. The people that have gone with solar have opted for battery packs, obviously, because if you don't have the battery pack, unless you're staying in the house during the day, you're not gaining access to it. The system or the house itself would have been sent to the north of Ireland first for fire testing. So the university up there, you had to bring up your panel, construct it up there, and they burn it from both sides. And you can watch it all on camera. It's very, very impressive. So we have ticked off all the boxes. When a county council, if you were new to an area, put in an application for planning, we usually touch base with the building control officer, which you'd never really see with general construction. It's amazing. If I brought a load of steel to a site and constructed the house on site, it doesn't need to meet any standard, while when you make it in a factory, it has to. So it's been very good. Our building control officer in Mayo has come in and watched several houses being built, taken pictures, and he shared them at conferences with his colleagues throughout the country so they can understand how it works. Look, we've been to America and we've watched modular construction for a long period of time. It's very new to Ireland and people have been afraid of it. But if you take the state of Pennsylvania, there's 33 factories making modular homes, or as we like to call them, factory built homes. in the state of Pennsylvania. And it's still only a tiny percentage of what they're doing in America. But we meet the American standard for snow and wind, which is 40% greater than Ireland. So we also have units in the States. Again, the COVID crisis slowed us down over there, but we're back in action now, and delighted to be able to be saying that we're working in America. So why you choose BRB Homes? It's full turnkey. You can come in and say, look, you deal with the planning. I just want a house. If we take your circumstances, the people in Belmullet and why a lot of them have chosen us is you don't have to knock your house to weave your house built here. So if you're doing general blocks and mortar, you got to level the house and start building from scratch. While when we have the house finished here in the factory, we can then say, right, we've it done. You can knock your existing home. So there's a huge saving there. Again, the cost of storage, transportation during your rebuild phase is quite a large cost, what the people of Belmullet had found, and they were finding it very hard to rent houses in the area. While this, 2 months really is all you're going to be looking for a home, which is brilliant. Our homes are all manufactured of steel, so again, it's not a timber framed home. A lot of people had concerns with timber framed homes in the past. We offer a structural warranty. Price comparison, as I said, there's a good €50 a square foot, which is massive, and it's fully turnkey. Most builders just quote to builders finish. We don't do any subletting by the kitchens. Everything is taken in control from the planning aspect, the engineering aspect, the plumbing, wiring, we're all in-house. The groundworks is the same thing. At the start, as I said, a lot of people are getting their own groundworks and we're finding delays. We have our own groundworks team now, so it's the same thing. We rock in and knock the house. We'll say if we take it in your case. All the costs are clearly identified at the start. So what an awful lot of people are seeing at the moment is the rising cost of construction and getting caught. A lot of young couples where they wouldn't have a house fully finished and they cannot get their last drawdown because the cost has got out of control. With us, if you're in a position to pay a deposit at the start, even before you go for planning, we hold the price at what it is that month. If you're not in a position for that, which the scheme doesn't seem to be, it's you go for planning, and once the planning comes in, then and you know the date you can start, the cost is there, but it's nailed down. Whatever we agree at the start is the cost. There's no hidden extras unless you go changing a design, which is great to know where you stand budget wise, because most construction sites are way over at the moment. We offer customization. So again, you can come to us, the plans of the house, we'll tweak it, but you don't have to go with a house out of the brochure. A lot of people feel that they only have to buy off the brochure. You don't. The lead times, which I've spoken about, 6 weeks we're on site. The house will probably be in the factory maybe 2 weeks, depending on the size of your house. And again, it's a very fast system. So when we get to site, you get to see progress very fast. You're not ringing the builder looking for him. The house at the moment we're doing in Cork, the young couple have started an Instagram page called Number 8 The View, which I may send to you later, Martine, you can share, but it's brilliant because they're there every evening sharing progress pictures. Now they took it upon themselves, but it's great, people, a great insight to see how fast it goes up. Our aftercare service, so if you have an issue, we'll have somebody out usually in 12 to 24 hours, depending on the part of the country you are. The issues aren't big, adjusting doors, maybe a small electrical thing. We've been very, very small, and our call out has gone very well. We're not busy with call outs, thanks be to God. And again, at the bottom, our chartered engineers are in house, so you're chatting with them all the time. They're able to tweak the drawings, chat to you in relation to your planning application if it's gone that say, or once it's gone out on site, if it's a mortgage drawdown or something like that. So that's the bones of it. I'd hope I've covered everything. There's a lot to sort of pack in, but we're from start to finish really, from the foundations to the kitchen to the paint. And I want to thank you very much for having me on. And again, as I said at the start, we change our name in 2 weeks' time to BRB Homes. The original name of Big Red Byrne has caused great confusion with people, the word Byrne. So BRB Homes will stand for Byrne Rapid Build. And you'll be able to get us on www.brbhomes.ie. You can still go on to modularhomesireland.ie. You'll get us, it'll all come back to the one website. But thank you very much, folks.
That's brilliant. Thank you so much, Donal. Will you be able to hold on for the Q&A? I think we do have Gerard Clarke in now from Fast Homes as well, and we have Jonathan Ballantine as well. So we have 2 more presentations to go. So I think maybe to hold the Q&A until after that, but are you okay? I know builders and construction are very busy, but can you hang on for about half an hour, like for Q&A?
No.
Yeah. So I just have Joe Mangan has stuck his hand up, but I'll just say, like, people would just hold your questions. We'll let the 4 companies go through, and then we'll do a short Q&A about 15 minutes after that. Okay, so Gerard, would you like to go next? Gerard Clarke, if you're there online, I see you're in. I can see you're in our panelist group now. Okay, or Jonathan, if you're there, if you're actually at the computer at the moment, if you want to go next, whichever one of the 2 of you. If not, we'll just go to a Q&A for Alan and Donal. Okay, so I can see Jonathan.
I'm here now.
Good morning.
Good morning, how are you? A bit of a hectic morning, sorry about that. Am I sharing my screen now?
Yeah. So so Donal, if you could stop sharing your screen, and then we'll let Jonathan share his screen. Brilliant. Great.
Can everyone see that? Is it okay?
Yes, yeah, great. Thank you.
Very good. First of all, thank you for the opportunity for allowing us to present today. Gerard Clarke is my name. I'm the sales and marketing manager with Fast House. We are one of the largest timber frame companies in Ireland. We would have a sister company called Frame Tech, so we also have a business in the UK. Together, we'd have a turnover of about 50 million sterling projected for this year. So, and we're continuously investing. We're looking at buying maybe another timber frame company or 2. So we are aiming to become a leader in timber frame offsite. Today, I was asked to speak on behalf of the Irish Timber Frame Manufacturers Association. I would be part of the marketing and technical committee for the ITFMA. The ITFMA was established in 1991, and we're the representative organisation for the timber frame industry on the island of Ireland. We currently have 17 manufacturing members, which the logos are on the screen there. And we have a further 15, what we call corporate members, which would be supply chain, timber frames, or timber suppliers, membrane, drywall, fixing companies, etc. So I suppose the objectives of the organisation, it came together because the sheer growth in timber frame. We went from 37% of housing, now that wouldn't include duplex apartments and stuff like that, but we went from 37% share in 2019 of housing up to 48% in 2021, and that's expected to grow even up to 70% share in the next few years. So we came together as an association just to make sure we maintain the quality and service of the product to the market, and we protect and develop the market, and encourage people to use timber frame while offering professional advice and support to our members and the market. So that's who I'm speaking on behalf of. I suppose when we're talking timber frame, because the sheer growth of timber frame in the 90s, the NSAI brought out a standard. It's an Irish standard for timber frame, IS 440. So if you're looking at building with timber frame, you'd need to comply with IS 440. If you're outside the parameters of IS 440, you'd need to look for an agreement certification or another means of certification. But most timber framers now are compliant with IS 440. So the NSAI will come assess and certify the manufacturers. So that's the standard that is being used. And so anyone planning to build a timber frame, it's a good benchmark to measure the quality of tenders. Your science certifier will rely on it for certifying it and making sure it's compliant with the building regulations. and it's currently being amended at the moment and should be released in 2023 as well. There's just new amendments to marry in with the new Part L. So that's really IS 440. When we're talking timber frame, there's I suppose the main way it's being built is panelized. Stick build is more an American thing where you're stick building it on site, but in Ireland the majority of it is being pre-manufactured or prefabricated, as some people like to call it. So the timber frame is actually built in a factory. There's open panel systems, would be more Northern Ireland really than ROI, but it's basically where you're just getting a OSB board and breathable membrane to the outside, and then everything else, all the insulation is being done on site and etc. Hybrid panel system would be really the standard product you're getting in Ireland at the moment. That's where it's pre-insulated in the factory. It would come with a service cavity ready for your plasterboard on the inside. It would come with the membrane ready for a brick outer leaf, and that's typically what you're getting. Closed panel is the future. We Fast House ourselves have been offering it for years. It's basically you can close it from the inside or the outside. From the inside, you're basically putting on your plasterboard. You'd have your services installed. You'd have your service boxes and conduit and stuff within the wall. If you're closing from the outside, you'd have your windows in. You might have a render board on the outside, etc. So that's sort of giving you a brief overview of what you're getting. IS 440 doesn't cover stick build if you're building on site. Doesn't cover typically SIPs. External wall insulation render systems on the outside wouldn't be covered in IS 440. So that everything in the Irish standard is basically allowing for a ventilated cavity to the outside. It does permit using other external cladding systems, but they have to stand on their own appropriate approval certification. Let's give you a brief overview. So timber frame buildings, I suppose, very popular really because it's off-site construction. It's unlike brick and block homes because you can start your construction off-site in the factory while you're doing your enabling works and groundworks on-site. So you're speeding up the whole process, less time on site. So all these benefits on this screen, you could pretty much say about any type of off-site timber frame construction. You're reducing the time on site, so you're reducing prelims and program costs. You're getting predictability of the program, of your delivery dates. You're reducing waste, material on site, so it's a safer site. And it's been made in a factory. It's a factory controlled environment, so less risk of failure in design and materials workmanship as well. You're less reliant on weather. So all these benefits are similar to any off-site construction. So I suppose what I'll try and do is just look at some of the unique benefits to timber frame. Just focus quickly on reducing the energy in a building, eliminating the negative environmental impact of your building. Just talking about high performance housing, high performance homes. When you're looking at a high performance homes, basically it needs to sort of incorporate many benefits. So first of all, the homeowner needs to have a better experience from comfort. That's everything from just bright, airy, clean, healthy indoor environment, good acoustics, etc. Low volatile organic compounds, safe on radon. Could mention pyrite and mica there because of today's event. The lifetime accessibility is important, and you want to live better. You want it easier for the homeowner, so less repairs and more money in your pocket from a high energy performance. So you have smaller bills and better energy efficiency. So basically, a high performance home should incorporate all those benefits. I suppose when you're building your house, you're probably, some people would say, why is it important to have greener home, low environmental impact? Well, we're all responsible for mitigating carbon emissions. Ireland is facing fines of 600 million a year for failing to meet 2020 EU targets, and we have 2030 and 2050 targets to meet as well. So we're falling well short of them at the moment. So the construction sector is a big contributor. Over 30% of Ireland's emissions come from construction sector. So we have to lower our buildings' carbon footprint. So I'll talk a bit about just that next. And then the other thing we need to do is reduce the energy consumption of our homes. So I'll talk about higher quality building fabric, stuff like that as well. Just talking about embodied carbon, timber frame is by far the lowest embodied carbon, lowest footprint. There's various research out there. One recent one that was done by the Passive House Institute compared 6 different building methods. It took a reference house in Cork, and they basically, I could spend an hour alone just talking about this, so I'll try and run through it very quickly. A life cycle analysis. So they basically took into account everything from the product being manufactured, the extraction and processing of raw materials, transport of materials to site, emissions during the construction phase, and then everything through the maintenance, repair and life of the building itself, operational emissions, and then even end of life. So assume 60-year lifespan on the buildings. And basically the conclusion of this research proved, I suppose, brick clad in this instance had 20 tons of carbon in the building, and the timber frame had 9 tons. There was 55% less carbon on that particular house. Oh, sorry, that was results on the wall only. So 55% less on wall only. So I suppose we took that, the ITFMA took that research, found it very interesting. What we done then is we took the actual wall types that were more common or more used in the marketplace, and we've done a variety of different timber frame wall types and compared them then to your brick block, compared them to insulated concrete formwork, etc. And timber frame, the 5 different timber frame wall types that were assessed, all ranked the highest. So again, it was just proven that the embodied carbon is very low for timber frame. And the outcome, really what we took from it is, if you could replace the outer leaf with a cement board and silicone render, there was further carbon reductions could be ascertained. The insulation type is an interesting one. Obviously cost comes into it. So some of these sheep, hemp, wool, wood fibers, there's plenty of insulation options. Cellulose was very good. We even have a recycled plastic bottle one, which is or PET recycled polyethylene wool. So there's various options out there. We probably found glass wool and rock wool was from a cost benefit analysis ranked very well. And PIR plastic foam, we found that the less of that we had in the wall, it performed quite better as well. The other thing we looked at then was reducing the amount of concrete in foundation. So I was unfortunately I missed the guys in the Terrapods and Terra Foundation, but that's the type of thing we'd be looking at in the future, where you're doing you're replacing that concrete. GGBS is very popular now, ground granulated blast furnace slag. It's a byproduct of iron manufacturing that they add to concrete as well to reduce the carbon, but there's huge savings can be got by reducing the concrete in the foundation. So I suppose just to briefly, timber is green, it's sustainable, it's renewable. So there's lots of I suppose I call it there the myths that the world's forests are shrinking. It depends where we're looking at, what we're comparing. If we go back 10,000 years, yes, 57% of the world's habitable land was covered in forests. There was only fewer than 50 million people back then. If we're looking back 35 years, there's actually more trees now than there was 35 years ago. European forests are growing, they're growing at a rate of 1,500 football pitches every day. So I suppose the point I'm getting across there is that the we are renewing the forests all the time. And timber is green. It captures carbon and it stores it throughout the life of the building. It doesn't release it when you cut it down and turn it into timber frame. So it's storing the carbon. And I suppose if you're building timber frame, it's just good to look. There's PEFC logo stamped on products is an example that we are procuring our materials in a sustainable way from managed forests. So that's just an important thing to mention. And then we're talking about offsite construction will reduce waste. So waste is an important thing when it comes to environmental credentials. So you're building in a factory which has procedures and to have less waste. Everything's itemized. There's reduced waste on site. So less material is less theft, less damage, less removal costs, safer site with less materials. Reduced transportation. There's a lot less to and from site of deliveries, a lot less noise pollution. You're on site for a much shorter time, so there's less disruption to the site and the location, less heavy machinery movement, stuff like that. So it's the benefit of the construction. If you're choosing a supplier, it's always good to look if they've ISO 14001, just shows that they're demonstrating environmental performance. They're managing their resources and reduction of waste and stuff. And then just getting into energy efficiency of the building itself then. So I suppose regulation and legislation has come in leaps and bounds since 2005. You can see reductions in 2008, 2011, and now the NZEB standard. So we're 70% improvement on 2005. So it's all going in the right direction. I suppose what we're learning when we're driving down the lower energy buildings, fabric first approach is becoming very important, where you focus on the heat loss through the building envelope and the fabric itself. So you're getting better U values, better quality windows, you're addressing your thermal bridging, and this all leads to better air tightness, which in turn leads to needing mechanical ventilation, and mechanical ventilation with heat recovery becoming increasingly important. So where to next? We've seen leaps in the standards, so we believe NZEB it's probably moving towards a passive house direction, passive house criteria, which is better. Again, you're getting into extreme levels of air tightness, 0.6 air change per hour. So again, it's working on a good envelope of air tightness, thermal bridge free, good insulation values, good windows, and then a good ventilation strategy with mechanical ventilation. So that's probably where it's all going. Timber frame lends itself nicely to passive house. The affordability then, off-site construction, because you're building faster, you've less time on site. You're quicker, you move in, you're reducing your exposure and your time frame on site, your exposure to costs escalating, which is very important nowadays. The material costs as well as labor costs are going up and up. So you're reducing hidden costs, you're more predictability, you're getting an exact and precise program certainty, guaranteed delivery dates, and your assurance of supply, which is important nowadays. So just to mention cost considerations, it's very important to engage. When you're dealing with off-site construction, you should engage your off-site manufacturer very early on. We can design out cost if we know early on. And the reduce prelims, reduce contingencies, risk of market conditions, as I mentioned. So quality, yeah, I suppose when we're looking at affordability then, because it's been built in a factory control environment, you have less defects and snagging that happens on site. So you're getting more, a higher quality product. And the whole life costs, building exceeds 60-year life, design life on buildings. So you've less maintenance and reduced defects and repairs. I think that's more or less, I think I've skipped through most of it quite quickly. I'd be happy to answer any questions at the end. Hopefully you found that okay.
Thank you so much. That was such an excellent presentation. Just generally for all of the presenters, if the questions are coming in, if you could share, if we could have the presentations later as a resource, particularly for our students as well, not just the homeowners. These are just wonderful presentations. Okay, so we'll move on to Jonathan, maybe, and then afterwards we'll take Q&A. So please keep your questions and we'll open it up then.
Okay.
Hello.
Hi, Jonathan.
Hiya.
Okay,
Sorry, I was
so
a bit late there.
okay.
Can everybody hear me okay?
Yes, Jonathan, we can. Yeah.
Okay.
But, yeah. Are you going to share a PowerPoint? I'll just ask Gerard, please, if you could stop sharing, and we'll let Jonathan share.
Stop share. Yeah. Okay.
Okay. Yeah. Let me just try that. Share screen. Is that working?
Yeah.
Yes.
You can see
Okay.
it. Yeah.
Right. Well, once again, thanks very much for the opportunity to come along and share something about ICF construction. We have been in the ICF business since 2004, and we've built quite a lot of units, as you can imagine, over that time. But a wee strapline that one of my employees came up with is ICF is the new standard of construction. Whenever we want to build something that is super built, that's another wee. Let's see if I can get this thing to progress.
No, if you, Jonathan, just see, yeah, that's grand. You can go that way. Yeah.
Grand job. So super built building with insulated concrete form. So that's a wee quick question. Is your house or new home or new extension going to be built that way? My name is Jonathan Ballantine. I'm the Managing Director of Ballantine Building Solutions, and we are the UK and Ireland distributor for IntegraSpec, which is what we feel is one of the most technologically advanced ICFs on the market at the minute. So I'm just going to talk a little bit about ICFs and what they are, and for those who maybe are not familiar with it. So it's 2 steps to a superior building envelope. So we're going to chat about what ICF is. We'll take a quick look at IntegraSpec, and then we can look at some pictures and draw some conclusions at the end. So ICF is a permanent concrete shutter. It's generally made from insulation, and most products on the market now are made from polystyrene. I mean, the original genesis of ICF goes back to probably 1950s, but it was first patented in 1966. And my first encounter with ICF was in 1992. So although it may seem new to some folks, it has actually been around for quite a long time. So there are different types, obviously, of ICF in the market. Most of these first ones that we're talking about are actually old systems, like the post and beam design, flat wall design. Most products out there are preformed blocks or knockdown blocks, like Nudura. But our product, IntegraSpec, is an independent panel, which we believe gives a lot more flexibility, and importantly for consideration on site, is a lot less waste. And ICFs can be made from different insulating products, but the vast majority are from high density EPS or expanded polystyrene. So building with ICFs is a very simple process. There's 2 basic steps. Yeah, assemble the walls with your chosen ICF and fill with concrete. And the result, which is easily achieved, is super insulated, airtight, with low thermal bridging, high thermal mass, reinforced solid concrete, which gives the homeowner the benefits of low energy running costs and a really comfortable home environment to live in, and also a very strong and secure building. Let me talk just a little bit about IntegraSpec and why we think we're the most technically advanced. So we're unique in the marketplace and where we have an independent panel, which means we can build walls of various thickness with only a few different products on site. Our panel is bidirectional, which means it's flippable and reversible. So what that means on site is there's no top and bottom or left and right to worry about when you lift the panel. Also, it cuts down waste massively compared to some of our competitors. We have an exclusive interlocking web, which has benefits from the builder's point of view, of no floating or form compaction. And our inserts are made of high impact polystyrene, which is chemically the same as the expanded polystyrene, so therefore it provides a very strong panel and gives you a lot of comfort when it comes to pouring the walls. User-friendly product line, the standard panel, and various accessory products like the corner sets, brick ledges, or IntegraBuck, which is very useful. So that means that's for forming around openings of doors and windows, the reveals, and because it's the same product, there's virtually no cold bridging around the openings, and also for renders, it makes it easy for the renderer because he's applying the render to the same substrate even on the reveals of the windows. So there's no chance of any differential expansion and contraction, so much less chance of any cracking occurring in the renders. As I said earlier, we can do a different variety of widths of wall depending on design and also depending on what U value you want to achieve. Sorry, hopefully I'm not flying too fast, but I can share this presentation later and people can take their time. So as I say, the independent panel gives some maximum design flexibility, and it has a lot of little features that make it very convenient for the guy who's putting it up. Like for example, the 1-inch cut line. So you very rarely need to get a tape measure. You can just cut the panel on the 1-inch cut lines and adjust your wall to suit the design to very close accuracy. Again, I've mentioned why IntegraSpec, so less handling on site, and the key there is a lot less waste, as 1 to 3.5% as opposed to 10 to 20% on some other ICFs. I'm going to fly on a little bit here. That's mentioned the interlocking web. I'll just show you a little picture of that. So that little interlock there is very important when it comes to form lift and the stability and the ease with which we can get really strong straight walls once the concrete's poured. That's another cutaway view of our panel, and it has the insert that's molded in there, which gives you a fixing point every 8 inches or 200 mil. So you can fix plasterboards to that. And I also mentioned the exclusive EPS box. Our panel is dovetailed on the inside. So that means when the concrete goes in there and it's suitably compacted with a poker or vibrator, it really grabs our panel. So there's a really strong bond between the panel and the concrete, providing a super airtight product with no need for any vapor barriers or air barriers. Once the walls are built and the concrete's poured, all that's left to do is fit your windows and finish the inside and outside. As I said, it provides a really super strong home. Sustainability. So in the UK, I know you guys are mostly based in Southern Ireland, but I'm sure it's pretty much the same. So 10% of our CO2 emissions comes from the construction of our built environment, but a massive 50% comes from actually using our buildings. So, and 27% of that is residential use. So don't be getting greenwashed. Remember, sustainability means constructing buildings that reduce our burden on limited resources. So wee example I have is the leaky boat. So if we have a leaky boat, do you buy extra bilge pumps or do you fix the leak? Well, obviously the answer is simple, you fix the leak. And that's what we would say that ICF does. It provides a super insulated envelope that means that you don't need so much energy to run your property. And that's the principle behind ICF. This next slide is just a quick picture of two buildings. I believe these are in the States. The one that's bright red would be a traditionally built timber frame house in America, whereas the one that's darker and blue is the ICF building. And you can see clearly the amount of energy that's released from both buildings. And I know the one that I would prefer. And we can achieve U values right down to 0.11. I think we can even push that even further, but with the addition of our standard panel, will give between 0.23, 0.24 to 0.23, and then to achieve your 0.18, we add an extra 50 millimeter on the inside of the panel. That pushes the wall thickness out a little bit to about 330, but you're still left with a 6-inch concrete core. And with our wider webs, we can add in an extra 100 or even 150 mil to bring it down to 0.11. I guess we could even go wider than that again if we really needed to. So the occupants of the building will see reduced running costs, improved acoustic performance, and due to the heavy mass of the construction, a really healthy indoor environment. ICF buildings, I describe them as the ICF walls are like a shock absorber. It takes a long time for outside temperatures to have an effect on the inside. Obviously, with careful design, using passive principles and orientation of solar gain, etc., you can enhance those benefits even further. I mean, we built a house for my nephew. I don't think I have a photograph here, but they've got a really strategically placed southern-facing glass wall, essentially, and they can run the building for, I think it's average of £47 a month, and it's a 2,500 square foot house. And whenever I say £47 a month, that includes their lights, their hot water, even their electricity for their heating. So that's all their energy costs is averaging £47 a month. I'll just show you some pictures of, actually there it is. There's my nephew's house. So you can see the strategically placed glass wall. So that wall brings in probably enough heat for the whole house for most of the year, even in the winter. If there's a blink of sun at all, it really gains heat. But the beauty of the ICF is that it stays there, it stays in the house, and the high thermal mass of the walls, plus maybe some of the internal walls are built with block and the concrete floors. So it's a very stable, comfortable environment to live in. I'll just show you, these are some photographs of walls during construction, or that's just at the concrete pour stage. Some of the other folks have talked about speed of build. This little job here, this was in Bude in Cornwall, and I arrived on site, and the time I got my flight over on the Monday, from when I arrived on site until we had it poured on the Wednesday morning was a total of 16 hours of build time. It's a wee bit of a record, but it just shows you how fast that ICF can be put up. I usually tell folks it's 6 or 7 days per story. And then if you can organize the internal walls and the flooring, then you can progress to the second stage pour. So it can reduce the time of construction quite significantly. So as I say, there's a lot more photographs on this presentation, but I'll, as I say, I can share this presentation with you. This particular picture is showing some serious rebar. Again, this was for a very tall wall, a 6 meter high wall, and that was designed to support the roof with the sideways loads. So that's why the rebar was in that, and that was in this project here, which was a youth centre in Kesh, in County Fermanagh. And one wee accolade that we got was this house outside Belfast won the Action Renewables Most Environmentally Sustainable Construction Project in 2016. This house is completely off-grid, so it's not connected to the electricity network, and they are a young family. They've got 3 young kids, and they live there as normal as anybody, with a backup generator for the cold winter nights. But during the summer, they actually have excess electricity, which they have a hot tub, which they heat with that. But the building envelope was a great contributor to the overall running of the building as an off-grid. So just an illustration of what's possible with ICF. And again, just for an example of an extension, which maybe not relevant here in this forum. But so I think I'll stop there, and if anybody has questions, I'll hang around for a bit too.
Great, thank you so much. Thank you. Okay, so looking at our schedule, Dr. Tom Woolley is on at 11:30. So we have, we're currently at about 10 past 11. We have 20 minutes. We do need to take a short coffee break. So if we take 10 minutes of Q&A now, because there's such rich presentations and there are a lot of questions coming in, then we'll take a 10-minute coffee break and we'll be back at exactly 11:30 for the next presentation. Okay, so we'll open up for about 10 minutes of presentation questions now. I'm not sure if my colleague, Dr. Rita Scully, is currently online. I can see she's there. If she'd like to.
I am, Martina, yeah.
Rita, this is your field of expertise. So I if you would like to, I think because it's so rich, I know you have another panel Q&A later, but there's just so many questions coming in.
Certainly, yeah. Just let me open up those. Right, just scrolling down through them. A few of them are just in relation to recordings, which I believe you've already addressed with it.
I think with the Q&A, Rita, there's some quite.
Sorry, just trying to see if I can get that to come up for me.
Okay. I might have to enable as host as well.
Okay, sorry, I've got the first one here. Don't know if this is coming from this morning's. Yes. So I think it's in relation to the first presentation. Is it complying with Part D of the building regulations? That's quite a long question in relation to that one.
I think that may have been the very first presentation that we had this morning.
Yeah, I think that was, is that Donal's or?
Yeah, the first was Terratonics, though, Alan.
Sorry, yeah.
Yeah.
So I don't know if Alan is with us at the moment.
Yeah, I am. Yeah.
Yeah. I think you kind of addressed some of this, that the level of assessment that's done with site production compared to manufacturing production, the manufacturing is significantly certified and robust with it, but it's particularly Part D of the building regulations that was being asked about.
Yeah, well, we aim for our system to comply with all parts of the building regulation, but as well as that, because our system's quite new in our version of it compared to the ancient version of it, that we actually have to go and create the necessary new certification to allow that to adhere to the current building regulations as well.
Okay.
Yeah.
So I know Donal referred to with in relation to their products going through the fire test. So it's the same idea that the building regulations or the building standards are there to be met by the various means. And obviously Donal, you'd have been doing the same thing with regards to fire regulations of assessing your materials and the final product as well, not just the individual parts, but the total component.
Yeah, it's very rigid the way they do it. You cannot make the panel in the factory and then bring it up to the test. It has to be made at the facility in Belfast. They count how many screws go in, how many nuts, how many bolts. You have to have a list of all your products, where they came from, and it builds up a pack. And I suppose because of the people Belmullet will say had suffered so much from the pirate, they might be the same as yourselves. They had such a fear with general construction, and for them to understand that manufactured homes are far more strenuously watched, and we have to tick way more boxes than the blocks of mortar on site, which people find it hard to get their head around, because they always see it as, or maybe manufactured isn't as good as blocks of mortar, when really we've gone way up above and beyond to prove.
Yeah. No, and I think, I suppose I'd have come from both traditional and modular. And I suppose what we see with the traditional is individual pieces are certified. But when they're combined, the final product, being the house or the building, that's not certified in the same way. You know, you've got an overall certification in relation to fire and planning regulations, but certainly not tested in the way your complete products are being tested once they're completed and combined together.
Yeah, that's correct. And the timber guys have a great setup there with their own industry, and the presentation was excellent as they've come together as a group, and you know, it's all there. Really the same thing is going to have to happen, if we can, for manufactured homes, to give people you know, I suppose, their understanding of it.
Yeah. And just one other question that came up there: do you provide an overall certification then, or would assigned certifiers still be involved in one-off houses?
It totally depends on the opt-in and the opt-out, but we can give a cert here with our own engineer. You can bring in external as well if you want. It can be just slower because they have to understand the process and come and inspect it more, but there's no problem.
Fair enough. I'm just looking here at another one I suppose particularly relevant. I know I'm not picking up every question, because as Martina said, there's quite a few, but just in relation to your products, Donal, do you look at doing just outside wall replacement? Because we had quite a number of discussions yesterday around where external block work had been failing in properties, and the general consensus was total demolition, including foundations.
Yeah, again, for us to stand over the product, we have to do it all.
Okay.
Don't do the wraparound. Again, there's too many moving parts for you to try and guarantee your product if you know there's an existing building there that you're going to try and wrap. So yeah, full demolition, new build for us.
Okay, yeah, I can see where the question is coming from to try and avoid it, but I take your point that if you need to stand over something, you need to be able to stand over all of it. So I'm just trying to pick up a couple of others here. This question here: should you be selling MMC without an agreement certification or FAR test carried out on the main structural elements? I'm not sure who that was aimed to. I don't know if we can get some clarity maybe on that question, if the contributor is still involved in it. Okay,
yeah, I think that's Richard Butler. So if Richard, if you could just clarify there the question, and we'll come back at it.
Yeah, or if there's someone in particular you want to answer that one on it. I think what I found very interesting was just where, like you were saying, Donal, where some of those comparisons of foundations, where there could be a combination of materials being used and combination of different methods involved within it, that it opened up, I suppose, other avenues and other options as well with the construction that was happening.
Yeah, people love the idea of sort of dealing with one company or one builder. It's the subletting and trying and pulling them all together and the coordination, even from an outside engineer point of view. And that's why we streamlined it. At the start, we would have outsourced all those little bits, from the electrical to the groundwork to the engineer. Now it's all in-house. It's just easier as the build is going on. We know it's our team. They will be there. We're not ringing a fella getting excuses. It's bang, 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 bang. And that's the way it needs to be. And that's why we introduced the interior design element of it in the furniture. Again, we're bulk buying products. So when you bulk buy, you get a good discount. And when people went off looking for, you know, electrical goods, they found that we were 10% cheaper. So it was just easier to walk into the house and everything in it.
Yeah. Yeah, I remember being at a conference probably about 20 years ago now on construction and what way construction was going. And one speaker made the point, he was from the UK, that it needs to move to the way airplanes are delivered. You don't argue with individual product suppliers. You're buying an end product, and there has to be one company responsible for the entire product. It seemed a little bit outrageous 20 years ago, but I think it's been proven time and again, it's really is the way to go with it.
Well, look, when you're in any of the factories in the States and their houses are different, I suppose they cut them in 3 halves.
Yeah.
But you see the couch and the fridge and everything in the house before it leaves the factory, all wrapped in plastic. You know, it's unbelievable to see the way they do it. And less stress, more success. The idea of having a construction site goes on for a year and a half. It's very difficult on a couple, especially when they're renting elsewhere. The rising costs of material, the change of environment. It's very difficult. So we have found, and we're only going on the feedback we get, that people just love this idea of one company, turnkey, and that it's a quick build.
Yeah. I think one point you made in the presentation as well, in relation to going back and speaking to clients about how they're finding their buildings, the usage of them. I teach in built environment at TUS, and it's something I push for students or companies to do more. It's a rarity. We're usually out the door and don't want to hear from a client unless it's a repeat project. So, you know, to get that feedback really strengthens how you improve your designs for any product and for any material that's being delivered to customers.
Yeah, we've been asked to do more of it, and we're going to. So when the weather improves, we're hitting out with cameras and sitting down interviewing people, getting more pictures, because people love videos. They love to see, you know, houses, how they've ended up finishing, how people are getting on them. They like real life stories and what's happening. So that's something we plan to do. And again, the great thing is we made an awful lot of friends with our customers. You know, these aren't just people that you've sold to and you never want to see again. We've become good friends with them. Some of them have come working for us, brought us on work, so on and so forth. So it's very important that you build that communication and that network. And it's people that have the trust and they know that they're not dealing with just a businessman. They can pick up the phone and have a call with you and bring you on to more business. As I've said, we're trying to get out of Cork there for the last 3 years. Once you get a house in an area, there'll always be another one. And it's a great way with word of mouth.
Yeah, it's a great strength to it. Okay, thank you all very much for that. I'm just keeping an eye to time here. So we've run over a little bit. Sorry, Martina.
Okay.
So
we'll take 10 minutes. Yeah, we'll just take a 10-minute coffee break and we'll be back at 11:30 and Dr. Tom Woolley is going to speak next. Okay.
Thank you.
Thanks, guys.
There now again. So we have Dr. Tom Woolley next, and we have Mairead Phelan, I've noticed, is back today. So Mairead is one of the overall, she was a speaker yesterday, one of the overall regulators. So I'll just bring up her point there. She's saying each product and the end product product must be tested, designed to comply with the requirements of Part A to M of the building regulations. How is this certification achieved? So maybe we'll just keep that question in mind. We will have another Q&A after the next 3 sessions. We have Tom Woolley, Sally Starbuck, and Sue Corcoran, and then at 12:15 to 12:30 we will have another panel Q&A session chaired by Dr. Rita Scully. So maybe we'll bring that question back in again. Okay, so Tom, if you'd like to go.
Great, thank you. Can you hear me all right?
Yes.
Yep, thank you very much for inviting me. So I'll try and rattle through this as quick as I can, because I think obviously there are lots of issues to discuss and people will have lots of questions. So I'm just a bit about my background. I was Professor of Architecture at Queen's University in Belfast, and now I do research and consultancy and training work on building construction. And on this slide, you can see some of the books that I've written on these topics. My latest book is about natural building techniques, and I'm going to go through the various bits of the book so that you can kind of get an idea of the guide that I've tried to produce. I mean, one of the main issues is that we hear a lot about climate change and what's happening to the planet and so on, but the important thing is what can we do about it, and whether we can do, when we're building houses, we can also make a contribution to saving the planet. I've been very much aware of the kind of problems that you were talking about yesterday for some time, and I just thought I'd mention that I got a very quite sad email in a way just recently from someone in Donegal who wrote to me, who reminded me that he'd contacted me back in 2004, and I'd urged him to build a house out of natural materials, but he went ahead and built it with mica, and he said, I wish I'd been brave enough to choose the green option at the time, because now he has serious problems with his house. Now, currently the Irish government and the building regulations to some extent are skewed to favour the use of synthetic petrochemical based materials. For instance, the SEAI technical standards don't mention bio-based materials that I'm going to be talking about at all. Breathability is not mentioned once in these technical standards, or vapor permeability, all issues which I'm going to touch on. And embodied energy isn't talked about. And embodied energy is the amount of energy which is used to create the buildings in the first place. People are still building with these sorts of materials: concrete blocks, steel, lots of thermal bridging, filling cavities with polystyrene installation, all really bad for the planet, and it's not really a very good way to build the buildings anyway. Synthetics are used to insulate houses. Buildings are being wrapped in plastic more and more, with materials which are bad for the environment but also bad for our health. And I didn't originally plan to mention anything about ICF, but I was a bit horrified catching the earlier talk. I thought that ICF had been killed off about 10, 15 years ago. And one of the things which happened was that the Building Research Establishment in Watford had built a demonstration ICF house, which actually they had to demolish it because they were so embarrassed about the amount of mold and damp that was appearing in the building. And I just had a quick look on the internet to find there are quite a few websites warning about the disadvantages and things. Surrounding yourself completely with polystyrene, which is a synthetic material which relies on flame retardants, and despite what you might find people talking about ICF telling you, the flame retardants are toxic and are damaging to health. So there are many problems with ICF, and I'm really actually very upset that it's making a comeback, because it's not the way we should be building in the future. The other issue which is becoming an increasing problem is because of using flammable, toxic, synthetic materials in buildings, we're getting more and more fires. Fires in low-rise buildings are much more severe because of the use of flammable plastic insulations. And you don't hear so much about them. You hear about the media focuses on fires in high-rise buildings, but you don't hear so much about the ones that destroy people's homes. The other downside of the way we build today is the problem of buildings which are not breathable, and they're sealed up with plastic materials, and this leads to mold and damp in buildings. And this is becoming is achieving epidemic proportions at the moment. And one of the things I don't have time to talk about today, but is one of my main areas of work, is about indoor air quality. And I've just put a picture on here of a very useful guide that's been published by the Scottish Ecological Design Association about indoor air quality. We can always come back to that later. I'm running lots of courses about these issues. I'm doing a 2-day course at the Centre for Alternative Technology in Wales in July. I've just agreed to do a similar but slightly compressed down 1-day course at the Rediscovery Centre in Ballymun in Dublin. And if you've not been to the Rediscovery Centre in Ballymun, I would strongly recommend it, because it's a wonderful demonstration of use of a whole lot of environmentally friendly materials. I think that's going to be the beginning of October, that course, but I'm not 100% sure. I work with the Hemp Cooperative Ireland. I'm a member, and we run lots of training courses around the country. There's pictures here from one in Kerry and one in Dublin. And I've just come back from Mayo, where we're planning to run a hempcrete building course in Mayo. So just coming back to my book here, it's called Natural Building Techniques, and it's literally hot off the press. And what I've tried to do is outline all the different kinds of natural building methods and that can be used. So how you can use earth in building, different ways of using timber, the importance of lime, straw bale building, hemp and hempcrete, and also all the manufactured natural materials that are now available, where you can get them from, and so on. So I'm going to run through these quite quickly. So building with earth, it might not seem to be an obvious way to build today, but actually it's a fantastic material if you want to create healthy buildings. And there are lots of things you can do with earth in terms of construction. Using timber is absolutely central to building in an environmentally friendly and healthy way. And there's lots of ways of using timber, and you can be using local Irish timber and not just imported timber from other parts of the world. And I go into this in detail in the book. Lime is very important. We should be reducing the use of cement and concrete. Cement and concrete are two of the most damaging materials on the planet, responsible for possibly up to 20% of carbon emissions. And so we should be using lime much more than we do. And I also look at straw bale building, and there's an excellent new book on straw bale building, which I refer people to in the book. Hemp and hempcrete is the thing that we do most of these days. Here you can see a picture of a recently completed house in Galloway in Scotland that is built with a timber frame and hempcrete. And there are many ways of using hempcrete. It can be cast. In this case, it was sprayed. You can make blocks. You can make prefabricated panels. There are lots and lots of things, and we're trying to develop the use of hemp and hempcrete in Ireland, where it's lagging behind a bit. Wales seems to be particularly active at the moment. We've done quite a few projects in England and Scotland and so on. So it's something which we're very keen to get people interested in. There are many natural manufactured materials which are now available. These are made from all sorts of bio-based materials, such as hemp. Recently, I've come across a product made with sisal, wood fiber, sheep wool insulation, and so on. There's a picture here of a catalogue from a French company called Biofib, which is absolutely amazing catalogues, just a fantastic range of products. And I asked them if they would be interested in promoting their products in Ireland and in the UK, and they said no, we can't be bothered because people in Ireland and the UK don't understand the importance of environmentally friendly materials. That was what their market research had told them. I was a bit annoyed about that, but maybe there are some real issues there. People still haven't fully understood the importance of using environmentally friendly materials. There's a section in the book about paints, and the different kinds of natural paints, and what about using recycle paints as well. I discussed that. And I also look at retrofit and renovation, because I think that's really important. People still there's a lot of talk about retrofitting buildings, but again, often using the wrong materials, which then lead to damp and mold growth. And it's really important to use natural and breathable materials in building. So that's just a very quick run through. I mean, I would love to go into a lot more detail, but it's not really possible in an event like this. I think the main thing really is that I want to encourage people to understand the value of using natural, breathable, vapor permeable materials, and how that's so good for both environmental impact, for having better health in buildings, and also providing a form of construction which is robust and successful. And also one of the great advantages now, for instance, with hempcrete, is that it's cheap. People would say, oh, it must be ecological building, must be very expensive, but actually the raw materials themselves are very affordable. And that, with the rising costs of building materials at the moment, that's quite important. So I'm happy. Appreciate. I've rather skimmed over this, but I'm happy to answer some questions and go into this in more detail when you want to do that. Okay.
Thank you so much, Tom. Yeah, it's very, very interesting and timely as well. Topic to be raising, and maybe we'll get some details as well on the workshops, any workshops in Ireland, so we can share that with the students also. Okay, so Sally Starbuck is next. Sally, if you're there. Hi, Sally.
Hi, good morning.
Nice to
I'm glad to share my screen.
Yeah.
Great to follow Tom there, because it fits very nicely. Can you see that okay?
Yeah.
Okay, so I'm sitting in Cloughjordan in Tipperary in the Ecovillage, and we built a purpose-built studio here about 8 years ago now. It's been a 20-year process, so I suppose the subheading of the subtitle of my presentation might be 4D design, because time is a fantastically useful commodity when you're building anything, and if you rush, I know speed is of the essence in certain things, but rushing decisions isn't a great way of making good decisions. So some of what I was going to say, Tom has at least introduced very ably there, so I might be able to move quite quickly. So just by way of introduction and context, this is a project that Paul Leach, my partner, designed in the mid-80s, I think, and it has just recently been published by Kilkenny in their Rural Design Guide as a good example of sustainable rural design for houses. And it's obviously passive solar and well built, good quality materials, durable materials, and all the rest. But it's a muff if in the showing. As I say, I'm in Cloughjordan now, and I suppose the intention of the community, and that's a significant word, is that we would live with very little environmental impact. And that is also a healthier way to live for everybody. And I think anybody who has suffered living in a basically, or suffering the consequences of unsuitable materials, toxic materials, and the health and anxiety and so on that goes with that, I think would appreciate having a choice in this matter. What you build your house out of is very, very significant. In the bigger picture, this is an aerial drone photograph of the Ecovillage, which is only half built at the moment, and is there are 55 houses, and there's a few more slides here with a bit more detail. Let's just give some context. It's, as I say, 55 houses. It's also an educational project. So the building on the left is a hostel where a lot of visitors come, especially actually third level, to see, I suppose, something of a social experiment, so the environmental innovation in practice. We've over 120 residents and a lot of businesses, including my own there, on the land. We have 67 acres here. And I suppose the principles were of sustainable rural regeneration, that there would be a lot of personal involvement for the individuals to develop as they wanted to, really. I suppose it's not intentional in the way that it would be dogmatic and people have to do a certain thing, but it is an educational charity. We have an international impact and, you know, from that local focus, because to be honest, these issues are certainly universal in the sense of the Western world, but I've also been to China, to the Beijing region, and it wasn't, you know, colossally different there. Obviously, the government system was very different. So one reason for being in Cloughjordan is that we have a rural rail line, which is a great asset. We have, there are 2 primary schools here, shops and post offices. So we did not build in the middle of the countryside. We built in the meadows at the back of a main street of a town, what had been a town, very low, a population that had begun to age and emigrate and decline. So we have increased the population by 55% just from the Ecovillage siting here about 10 years ago. We have, as I said, 67 acres, and we only developed a third of that with buildings and underground infrastructure. We have a third given over to woodland and biodiversity. We have a community farm, that is community supported agriculture, where the farmer is paid and the members of the farm are, you know, pick up their vegetables once or twice a week. And we have enterprise and energy, and the energy is a biomass fueled district heating system around the around to each house, providing hot water. We sign up to an ecological charter, which is an agreed set of standards, including biodiversity and other things, as well as energy. So we obviously have a shared wastewater treatment system, and so one has to be careful how that is managed. And we have sustainable urban drainage. Obviously helped a lot by the planting that we have done. A lot of the trees planted are fruit trees. So this is all very much within the permaculture model, if anybody is familiar with that. And then the houses are generally high performance, low energy buildings. Vast majority are timber framed, and that would predate the current methods, you know, of mass producing timber frame houses. Passive solar design with low embodied carbon, but they're not, none of them are alike. So we have lots of different designs. We have a couple of passive houses, but they really, that's an overinvestment on behalf of the owners, because we have the district heating system and you know, a basically fairly mild climate. So some people have installed PV on their roofs, and but the district heating system is community owned, and that's using waste wood from a local sawmill. And then we have a biodiversity objectives very high. We have the newly planted woodland, and then this is a very ancient woodland on the site. So I suppose economic factors are very, very important, but they're built around not growth, but resilience. You know, we have food is very central to that, as well as energy, transport. So it's running along the same themes. I mean, it's not very relevant to a lot of people here, but it's just to give you the context. In practice, as I'm an architect, I've been doing some life cycle analysis, which was mentioned earlier by one of the previous speakers. So I don't need to go into detail there, but yes, I agree. Obviously, timber building in comparison with steel or concrete frame is hugely reduced embodied energy and carbon. The important fact here is if we build everything that is in the National Development Plan out of conventional methods, i.e. concrete, that will consume the entire carbon budget that we have set ourselves to 2020 to 2050. So we just simply can't do it. I mean, there's no question of any, and there's no need to do it. There's more importantly, it's a much more sympathetic method of building for homes in particular. It's more flexible. It's not factory produced. So I'm not plugged into power, just let me do that. So this is a methodology, one-click LCA, which is very useful. It means that we'll be able to compare different buildings and see who is achieving the targets, which are fairly flexible. To be honest, the targets are not at the moment too demanding, and conventional construction would just scrape in as long as it wasn't ridiculous. We have looked also at modular frames using locally sourced timber and probably self-build, to be honest, and there's open source timber technology, which really is worth exploring because it is a fantastic system, in my opinion. It's developed in Wales, where they have very similar low quality, frankly, fast grown sick forestry industry. And it's using that timber and adding value to it by clever technology and good design, and then creating a modular system, which is very suitable for housing and even self-build, as I say. So there's a couple of events where we were exploring that with hemp, actually, it has to be said, also infilling the frame. So this is the building project we completed in Cloughjordan for 2 clients, 3 live-work units and our own, including our own, and that is using hemp lime construction. So the building is 3 stories. You can see it under construction there on the top left, and the lower left, that is the hemp lime going into the shuttering on the wall. And then the 2 areas of green lime render on the bottom right, they are the finished hemp lime wall with a lime render to protect it from the weather. And that performs very, very well. It is a super material. It also performs extremely well. I'm not sure that Tom mentioned, it performs extremely well with moisture and humidity. It has absolutely, frankly, magical performance. And this is where I'm just going to insert a bit of polemic, because the vast majority of energy in this country is burned to dry the house inside and not to heat it, because we have a mild climate, yet we have a humid climate, especially on the coasts of Mayo and Clare and Donegal. So the number of sort of summer evenings you see a fire lit and smoke from a chimney is because the house is damp inside, or dank inside, and that is not a good use of energy. But if the building fabric is managing the moisture in the room, which exists because we're living and breathing in it and washing and cooking, then the need to burn that energy is vastly reduced. So it will improve the energy consumption of the house, and also the comfort and the indoor air quality. So asthma and other respiratory illnesses are not so agitated when the building is at a good moisture content in the air, and not too damp or too dry, actually, either. So both of those apply. The passive houses would have a tendency to be very dry inside because the air is moving all the time out of the house and being brought in. The air is being conditioned through the mechanism and is therefore drying and drying all the time. Excuse me. So moving on. So as I say, hemp lime construction insulates. It deals with indoor air quality, vapor control. It's also got good fire resistance. Energy performance, as I say, exceeds its calculated value, and it has, because it is basically massive monolithic walling, a good noise transfer and acoustic performance. And it cures lime. Carbon dioxide cures lime, so it's a carbon neutral material. Now, in our own practice, we also have colleagues in Scandinavia, largely go international, and this is a study visit we made to some innovative housing and retrofits and, you know, different users and materials. So I'm just grounding this in the science here, where on the right you will see maps of moisture in the air and when that condenses out and what happens to the building fabric, and also the occupants when that moisture breaks its dew points. And obviously you get condensation, you get mold, and all of those problems in a sealed moisture impermeable building fabric, such as, well, gypsum plaster is true, but also the polythenes, the plastics, the steel, the concrete, and the insulation materials that are conventionally used. So then interior might be either stuffy or Baltic if you keep having to open the window. So you need to deal with the moisture in the air and air tightness for comfort, obviously. For energy efficiency, you don't want to be losing air to drafts. So adequate fresh air, and using passive solar to keep the temperature pleasant as well. So that's all of a package really with these breathable materials, and it's effortless, frankly. And obviously your ventilation system, which I don't think anybody's mentioned yet this morning, is crucial if you are building an airtight building. So without a well-designed ventilation system, and it doesn't have to be a full fan system, you will have discomfort, and possibly, as I say, asthma and other things will become worse. The houses there in the middle of the shop, that's our studio in Cloughjordan, that's naturally ventilated. We have a stack effect in place, and the air quality is brilliant. Even if the house is left unoccupied, it's not a problem. So moving on quickly, we have an ecological footprint analysis done by Vincent Caraha at Galway, and that was looking at transport and all other aspects of life. And these are the results which just show that the Ecovillage is a half the impact of a typical Irish settlement, less than half that of a commuter settlement, and that is on the breakdown. And you can see that's with air travel at a relatively larger slice of the pie, because of our educational brief, if you like, and our travel to conferences and so on, it was relatively higher than, say, the proportion of people in Ballantine were traveling by air. So it's obviously car is reduced somewhat from say a typical Irish settlement because and commuter settlement in particular because of the rail station. But food is a big sector on the typical Irish settlement because of transport. So this is just summarizing that, and that was on the study of 79 other settlements. I mean, I have quite a lot of slides on this, but I just finished there, that we could argue about this sort of thing for a long time. But basically, it's another important thing is not to agonize too much about the structure of the building, because it's only about 20–30% of the total building project. And your main decisions are going to be how big is the house, where is the house, how big is the house, and with good design it does not need to be big, and then you're starting to make savings already. And if you think sensibly about the other parts of the house, the services, that's about a third of the house build as well, how you service it with the plumbing, heating and electrics, and then the fittings and fixtures in the house as well. So finishes, roof finishes, windows, all these things we haven't talked about this morning are hugely significant decisions. But my overriding point is that if the group of people are working together, then you make the whole thing much simpler, and you can easily reduce the stress of these decisions, and just move into a more, I suppose, you're sharing ideas, you're sharing technology, and the decision making becomes a lot more straightforward, because some people are good at some types of analysis and other people are good at others, and some people are just very practical and like to get on. So that kind of overlap is brilliant, and exactly what you need to, especially getting projects started and off the ground out of a difficult situation that you might find yourself now. Thank you very much. I think, am I on time?
Yes, thank you, Sue. That was
track of time.
Thank you. Okay, so Sue, if Sue Corcoran is online.
Sorry, Martina, I didn't hear that.
Sorry, we're fine. I'm just checking in there with Sue to see if Sue is at the computer at the moment. Sue is on next. Okay, just double check there.
Hello, can
Hi,
you hear
Sue,
me? Hi, I'm just trying to turn on my video now.
Okay.
I think it's happening. Okay,
Brilliant.
great.
Okay.
Good afternoon. Sorry about that. So, will I share my screen?
Yes, please. Thank you.
Okay. Okay. Sorry, now I'm not very familiar with the Zoom. Haven't used it in a while. Okay, share screen. Just bear with me a moment, please.
Right, so I have your presentation on this side as well if we have any problems. So
Great, good to know, Martina. I think I should be good. We're getting there.
okay.
Okay, you should be able to see that now.
Yep.
Great. Yep. And can you hear me okay?
Yep.
Okay. Sorry now. Just bear with me. Sorry, my notes have gone missing. Okay, so you can still see the PowerPoint presentation, I hope, yeah?
And if you want to go full screen, but it's
Am I not full screen? Okay.
Yep.
You want to go to presentation now?
I am, but you see, I have two screens, so apologies now, folks, because I think you're seeing, you're not seeing my full screen.
I understand. You can go from that as well, so it's fine. Go
yeah,
from that,
I might do that because our what I'll do is I have a PDF there. It might be easier. Or Martina, do you want to share your screen?
Sure. Okay.
Yeah.
There now.
Sorry about that now.
Oh,
it just might be easier.
Yeah. You can see that okay?
Yeah, perfect. Okay. So hello everyone. My name is Sue Corcoran and I'm program leader on the BA Honours in Interior Design at the Technical University of the Shannon, Midlands, Midwest. Martina, you can move on to the next slide, please. So Martina asked me to do this talk on interiors and home. And I suppose there was many different directions I could have went with that, but my feeling was given, the homeowners who are joining us today are effectively in crisis, and I want to share some considerations for how you might rethink your living spaces moving forward in this journey that you find yourselves on. Martina, if you can flick on, please. Thank you. So I took this poignant quote by Claire Cooper Marcus, a landscape and architect educator, from Martina's website. The loss of a house to divorce, death, urban renewal, or natural disaster is a traumatic experience, as devastating for some people as the loss of a loved one. The best one can do is to nurture its meaning. So Claire Cooper Marcus, in her book, House as a Mirror of Self, Exploring the Deeper Meaning of Home, goes on to discuss how people not only feel anger and rage, but also violation and grief, and that the loss is not just of material possessions, but also part of self. So I can't fully understand where, ye as homeowners are coming from, because I haven't experienced, the stresses and strains that you've been subjected to by the impact of the use of deficient concrete blocks. I do, however, I suppose, understand when faced with a real crisis, the need to, survive, accept what is unfolding, and be informed so we can have some control over the situation we are faced with. So over the next few slides, I want to share with you some insights into considering your living spaces that might help you in your next chapter. Okay, Martina, if you don't mind going on. Okay, so the right to adequate housing is provided for in the Universal Declaration of Human Rights. Adequate housing must provide more than 4 walls and a roof. A number of conditions must be met before particular forms of shelter can be considered to constitute adequate housing. These elements are just as fundamental as the basic supply and availability of housing. For housing to be adequate, one of the criteria is habitability. Housing is not adequate if it does not guarantee physical safety or provide adequate space, as well as protection against cold, damp, heat, rain, wind, other threats to health and structural hazards. So, all things that you are experiencing currently as homeowners affected by this blight. Martina, if you can move on to slide 5. The stages in Abraham Maslow's original hierarchy of human needs consists of the needs lower down to be satisfied before attending to the next stage of needs higher up in the pyramid. And I suppose the diagram here just shows this in the context of homes and you know, our places of sacrilege, philosophical, physiological needs, including the basic needs for shelter, then safety needs moving up the pyramid to love and belonging. So I suppose this asks, can your home help to enhance your connection with family and friends? Moving on, can a house nurture you and support you and make you feel confident and express your individuality and help your esteem? Lastly, at the top of the pyramid with self-actualization is where we are considering if a home can support your purpose and potential. And I suppose ultimately a well-designed home should do all of these things. Martina, if you can. Thank you. So just looking at well-being and home, they do go hand in hand. Home is where we retreat to be by ourselves. It's a space in our lives designed to comfort us and to make us feel safe. The meaning of well-being and comfort are not dissimilar. And I suppose this graphic here is from the WELL building standards, which takes a holistic approach to health in the built environment. And it addresses behavioral and operation as well as design from a well-being stance. While it's predominantly, I suppose, for commercial interiors, its principles can be applied to residential settings also. And, you know, this is relatively new. So we may see, you know, things like this expand into domestic situations going forward. It's the first standard to focus solely on the health and wellness of building occupants, identifying design strategies and policies that can be implemented by owners, designers, engineers, contractors, and so forth. So it's a performance-based system for measuring, certifying, and monitoring. So it's just a good basis, I think, for maybe looking at any interior space and how we might design them in the context of those concepts. Okay, Martina, please. Thank you. Okay, so this is also, I suppose, from the well-being standards, and just you know, well-being in interiors obviously means many things, but I suppose from a physical and well-being point of view, environmentally conscious interior designs should always ensure human health. And you know, you're obviously in a situation where, you know, people's health is compromised currently with this scenarios you're finding yourselves in. Comfort, when looking at interior designs, comfort feature should help to reduce stresses that can lead to chronic health conditions. Elimination of environmental pollution prevents the exposure of toxins and compounds that interfere with the endocrine regulations of many of the body's functions. Stress and exposure to environmental pollutions can negatively impact health and lead to development of chronic conditions that reduce the quality of life. So in the interior, building materials should be absent of toxins that should be harmful if absorbed through the body's outermost layers. And I suppose, you know, Dr. Woolley spoke a little bit about that, and he obviously has a lot of published material as well where he focuses on, you know, healthy materials. Which would be very helpful for you if you're moving into this space of trying to create different environments to live in going forward. Healthy interiors should help to promote optimal respiratory system functions by improving the quality of the air we breathe through elimination of environmental pollutions in air such as tobacco and VOCs. So this was also mentioned, I suppose, a few times this morning. They're volatile organic compounds, as you would know, and they're a large group of chemicals that are found in many products that we use in building and interiors. So I suppose we are moving away from this, and companies and governments are getting a bit more organized about it, but it's still quite slow. So when these chemicals are in our homes, they are releasing an off gas and into the indoor air quality. And Sally just mentioned that in her talk, you know, the importance of ventilation in airtight homes. So if we have, you know, unhealthy products in airtight homes, it's obviously not a good scenario. So historically, interior products included paint, varnishes, chalks for ceiling joints, adhesive, carpet, vinyl, flooring, composite wood products, upholstery, and foam, to mention some. So I suppose factors to negate this in your design going forward and considerations for it. You know, good design will allow for comfort features that will mitigate and reduce stress, preventing the likelihood of, you know, all those negative impacts of unbalanced hormones and other negative impacts on our various bodily systems. The use of non-toxic materials will limit the exposure to chemicals and limit exposure to molds and microbes, which I suppose is something that a lot of you are currently experiencing in your homes. And also, you know, universal design and ergonomics can help to, you know, help improve posture and alignment and limit physical stress. So, you know, good design should effectively address all these things, looking at the human in the center of the space. Okay, Martina, if you can move on, please. Okay, so just to mention, I suppose, you know, there's a lot of maybe preconceptions about what interior design is, unfortunately, and a lot of people feel, you know, I suppose it's just assume it's interior decorating, but I suppose it's a lot more than that. And it's really understanding how the man-made environment impacts human health physically and mentally. And I suppose our primary concern with interior design lies with improving people's experience of space. So we can do that through looking at space, light, view, air, spatial layout, spatial flow, and the interplay of, you know, all those things with materials and finishes as well. So, you know, if you are, I suppose another aspect to consider here, if some of you are looking at rebuilding your homes, is, you know, maybe you're looking at an opportunity to review what stage you and your family are at, and to maximize the most of your space moving forward, to kind of suit your needs now and into the future. Okay, Martina. So I suppose just to look at, you know, the next few slides, just to give some considerations for you to look at your existing situation in terms of your site. So I suppose through the discovery and understanding of properties of the existing site, the interior can be enhanced and make connections between its surroundings and elements within. So, you know, some of you may have built your homes and, you know, at the time would have thought they were your dream homes. And I suppose, you know, just looking through some of the content with, you know, on Martina's blog, you know, for a lot of you, it's obviously been a hugely traumatic experience. So it's trying to rebuild and reestablish your lives going forward. So just in terms of, you know, if you are looking to use the existing site that you're on, you all know this intimately, but your previous homes may not have responded to that. And so I suppose it's about looking at the quantity and the quality of natural light in the environment, and seeing how you can enhance that in your new building going forward. So if, you know, the orientation and the site are considered, you can really, you know, have very positive experiences, and it can enhance your well-being. So you're just aiming to harness that natural light as much as possible and avail of external views. So cherish the sunlight in all its form, from morning sun in the east to evening sun in the west. So you're getting to know how the sun might move around your house and orientate the orientation of each room. So, you know, in your existing dwelling, you may have a situation where you have some rooms that are, you know, north facing, and they're not really getting the you know, the best south light. So you might look at locating some of those spaces to where the light is if you're spending a lot of time in the house. So, you know, we've all been stuck at home for a long time. So, you know, you've probably had time to think about this. So it's just getting tools now to maybe see how you might be able to improve you know, your next iteration of your house, and how you can use your site, your existing site, to do that. So just here, I suppose, are some diagrams that you're seeing, where just simple exercises showing the light and the sun moving around the house during the day, and how you might capture that and put, you know, key spaces in those places where there is the best natural light. Martina, if you can move on. Thank you. So just a simple diagram here, just showing, I suppose, you know, how, you know, the impact of certain window types maybe within a space, and the visual treatment of window frames in each case can either emphasize or minimize the perceived limits of interior space. And I suppose interior windows can, in a similar manner, visually expand a room beyond its physical boundary, or allow it to become an integral part of the surrounding, you know, bringing the outside in, which is quite, you know, this is not, you know, okay, it might be on trend, but it's just, it's being sustainable, and it's trying to gain as much as we can from the natural resources. Martina, if you can move on, please.
Yeah. Sally, I just say I'm just watching time now as well, so maybe
Sure.
a couple more minutes because we have so many questions. It's fabulous, but we just have to
Yeah,
get the questions before lunch as well.
Sure.
Okay. Yeah.
Okay, so you can move on there, if that's okay. Okay, so another thing that is worth considering is just height, and I suppose it's something that we overlook in an Irish context. And height in you know, can really just, you know, vertical dimensions can really influence, I suppose, space positively. And we don't need a huge amount of space to live, but with clever, I suppose, use of natural light, changing levels of spaces, it can really give the illusion of a much larger space. Okay, Martina, you can move on there. Okay, so just, you know, again, some maybe tools, like the top image there on the left-hand side is just showing, you know, like sizes of accommodation to set to a certain scale, just breaking down maybe spaces that you have and that you need and moving them around almost like a jigsaw puzzle until you have something that's a bit more concrete, that's becoming a bit more like a plan. And using this in conjunction with precedent images, like you're seeing here on the right-hand side. I mean, it's quite a normal house in an Irish context, but that can really help for you to kind of build your story and get your head around maybe what you're going to do with your next build. So just moving on to the last slide there. If you are interested in passive houses, I suppose you really need to do your research. And this is a house designed by architect Miles Sampson. He's this house is based in Ennistimon and it's on Airbnb, and there's a link there. So, you know, it would be of benefit to go and maybe stay in some of these places and experience them. And Sally mentioned about the hostel up in the Ecovillage in Cloughjordan, and that they do, I believe, maybe visits every Sunday at 3 p.m. and that is definitely something worth doing. So just to mention, if you are engaging with professionals, choose wisely, as they're not all equal, and you want to work with somebody that you connect with and can trust, and I suppose just listen to your gut. So the last slide there is just showing a couple of links just around, you know, I suppose, you know, mindful materials, and just this LBC red list that might help you just if you are looking at particular materials. Okay, I just want to close by thanking Martina for the opportunity to present, and I think what you're doing, Martina, is really courageous. And, you know, when in crisis, there are a few of us who are able to stand up and fight. So, you know, well done for what you're doing, and I just hope that this gives some food for thought when considering, you know, all the homeowners here, your next step for your new home. And just want to finish off by saying I wish you all well. Thank you very much.
Thank you so much, Sally. Sorry, I wasn't out. The computer, every time it was cycling, it was moving the slides there itself. It wasn't me moving.
You're fine. You're fine. It was perfect. Sorry, you had to do that now. An extra job for you.
No, you're great.
Okay.
Thank
you.
Thanks. Brilliant. So many very rich and thought-provoking presentations there this morning now. So I'll ask Rita to come back in. Please, we're heading up towards lunchtime, and maybe we'll just take the many questions that have come in.
Hi, Martina. Yeah, I'm just looking at the Q&A and the chat there. So there was a throwback question there to Donal that came up for clarity. I don't know if Donal is still with us. So I'm not sure if he's still on the panel. I don't think he is. I'm not seeing him there.
He may have gone out, but it's okay because we have them recorded anyway, so we can.
Sure. Yeah, it was around that certification issue. And there was a similar comment that came in the chat as well. I suppose more of a statement than a question in relation to that one. Sorry, I'm just trying to get that up. Sorry. So this was where they were talking about where each product and the end product itself must be tested and designed to comply with the requirements of Part A and Part M of the building regulations, and how is that certification achieved. So I know with Donal's, he spoke about the completed product basically having to be brought up to that university in Belfast where they are certified to do those testings. And one of the areas he spoke specifically about was the fire testing element of it. So they would, in those fire testing situations, they basically burn them to destruction. And it's looking at how long that takes, because you'd have different products that are certified to 0, half hour, 1 hour, 2 hour, 3 hour and beyond. So that's usually the type of process that would go in. And Tom, I'm just seeing your hand up there. Maybe you can come in there because that was a general chat comment that came into it.
Yes, one of the things about burning buildings to destruction is if you're trying to burn hempcrete to destruction, you can't because it doesn't burn. So they, after an hour's fire test, they generally give up because nothing's happened. So it's one of the great things apart from all the other things, and Sally mentioned some as well, but whereas other things will burn literally in minutes, so that's the difference.
Yeah, and I know you brought up that point in relation to having to apply fire retardants to many materials in order to achieve the minimum certifications required in those areas. Sally, you're coming in there.
Yeah, could I just jump in there? I mean, in dwellings is Part B in the building regulations here, and they have now sort of codified that in its own technical guidance document, whereas before it was very much taken as common sense. But the common sense hasn't worked, and in fact, a lot of people die of fire incidents in bungalows because they can't get out the windows. So window design is crucial, even in a single-story building, certainly in a two-story building. And the little windows which just have a casement light at the top, a vent light at the top, or 3 in a row, you see them all over the country. I think they should be banned actually, because I don't see the point of them. Ventilation, but why have 3 on? It's for security. People always worry about security, but there are ways to secure a window other than not having one, And the other thing is badly installed wood burning stoves have been a tremendous cause of fire. Again, in masonry houses, because every roof in the country is timber, and they have been quite catastrophic. So always work with specialists, get the right advice, preferably have it designed in the first place because those things are, and back boilers as well, it's like having a bomb in your house really, and you need to know how to have had it installed properly. That's I want to just chip in on fire because we haven't said too much about it really. It's sort of taking it as read, but you can't because people do foolish things thinking what's the risk, and there isn't.
Yeah, I think both Tom and yourself touched on the air quality and ventilation, that there's been that contradiction with the building regs as they've developed over the last probably 5 to 8 years, with an increased emphasis on retaining heat within buildings and reducing natural circulation of air. And I think, like you say there, in relation to the ventilation and the opening of houses or windows, certainly in commercial buildings, it's more and more automated air conditioning that's being brought into it, which is then challenging the environment and the power usage that's going on with that. Sally?
Yeah, I forgot what I was going to say. What did you start off saying? Sorry,
the air quality.
The things, yeah, the indoor air quality. So they've just recalibrated the radon survey in Ireland, and there are dangerous levels of radon in Ireland. And that is another thing that has suffered because it was kind of in a different section of the building regs as well, same as ventilation. So there would be concrete houses with, UPVC windows and polythene, membranes, which are collecting radon. Essentially, they're fantastic vessels for collecting radon in. And so, you see your stomach cancers and your lung cancers. I mean, 1/8 of the lung cancer deaths in this country are non-smokers. They are people who presumably have picked up it from radon in the environment. And you can only do that inside buildings, and the building you're mostly inside is your house. So radon is not to be overlooked as a real threat. I mean, there are it's to do with the geology, and there are places much worse than others, but the news is that they have just revised the survey levels upwards. So there's more radon than we were previously aware, because it has to be surveyed all the time. Thanks very much.
Thanks, Sally. And Tom, you wanted to come back in there?
Well, just briefly, because Sue made a very good point about the endocrine disruption, which is incredibly critical here, that people don't really understand it. The medics don't really talk about it, but there are so many building materials now in buildings, which people, as buildings become more airtight, people are subject to them at a much higher level. One of the things I've been learning about recently, which I wasn't aware of, was PFAs. We think of PFAs as a problem with non-stick pans, and we've been throwing out all our non-stick pans or trying to find a way of recycling them. PFAs are widely used in building materials. I had absolutely no idea until relatively recently. It's known as the forever chemical. And then there are so many carcinogenic materials. I mean, radon, as Sally says, is a really serious problem, but there are many other materials used in buildings. Even something as simple as gypsum plasterboard. Gypsum plasterboard is now made from recycled waste materials, from power station waste and other things, and actually emits all sorts of nasty substances. And the industry and the medical profession are largely in denial about this. They're trying to ignore the fact that there are emissions in buildings, and it's a really important area. And what I'm involved in air quality research work in the UK. And I know there's some good people working on this in Ireland, but we don't have any groups in Ireland like we do in the UK that bring people concerned with air quality together. And that's really important that should happen in the near future.
Could I just ask you there, Tom, because something came up yesterday, just absolutely shocked me. There was a comment that from this waste materials like carbon-based from the power stations was being put into concrete products. And it was said by everybody on that panel, it seemed to be a regular thing for industry. Surely that's going to cause, that's going to cause health implications.
It depends what the level of emissions are. I mean, one of the things I came across when I was writing my book on building materials and health was an 8-story apartment building in America where the radon levels were higher on the top floor than they were in the basement. They couldn't understand why until they discovered that the radon was actually coming from the concrete, from the aggregates that we use to make the concrete walls. But I've had battles with a certain company, I, for legal reasons, prefer not to mention them, who make their concrete or their cement from blast furnace slag. Well, there aren't any blast furnaces in Ireland, so guess where it's coming from? It's coming from the other side of the world, and it's full of all sorts of heavy metal contaminants. And they're putting that into concrete, and they are advertising that as the most sustainable material. And they are lauded by organisations like the Irish Green Building Council, and I just don't understand it at all, because surely we should learn the lesson from pyrites and mica and not start using other stuff that's full of strange and dangerous additives. I mean, I just don't believe it. But I mean, the main thing with concrete and cement is to just try and minimize its use. I mean, it really, you probably can't avoid it altogether, but and certainly not surround yourselves with, I mean, that's why I was so upset to hear about this ICF thing. I mean, surrounding yourself with polystyrene and concrete, I mean, what could be worse? I just cannot imagine anything worse than, why would anybody want to live in a house built like that? It's just beyond me entirely.
Tom, so there's a second thing you brought up in your presentation, which is about mold. We're having noticing in a lot of these houses, whatever is happening with the pyrite and the expansion of the block, it's bringing in the impact on the inner leaf is a lot of black mold.
Yeah, it's a massive problem, and we've made some very interesting contacts recently in Finland, where they've been doing a lot of research on this, because they have big problems with mold, particularly in schools, and it's actually affecting the health of children. I'm going to a conference of the British Society of Ecological Medicine towards the end of June, where they're particularly concerned about this and looking at medical solutions for the health effects of mold. And they are not aware that you can actually do things with buildings. I mean, Sally referred to, and I didn't say enough about this, she was right, about the things like hempcrete being hygroscopic and therefore able to regulate humidity in buildings. We know humidity levels are far too high, and that creates the breeding grounds for mold. So she was very right to draw attention to that.
Yeah, I would just add, actually, if I may, there's very well, I suppose since COVID, actually, there's increasing, but it used to be very low cross pollination between medical research and building in occupancy kind of research, and that's where I got my figures about lung cancer, and I was very worried at that time that, you know, the smoking ban was meaning that people couldn't smoke at work or on public transport, so they were going to smoke at home more, perhaps, but certainly they would smoke at home, and they were moving into, you know, more sealed buildings. So the chances of passive smoke or even your own smoke hurting you more so were increasing. But that's one small thing. But there are so many things like that, and I think COVID has made. I mean, it didn't happen immediately, and Orla Hegarty at UCD has been really on a soapbox about this now, that we really need to think about ventilating buildings as a public health issue, schools obviously, but nearly any building. And so she has been very prominent in the media in the last year or so on this, but it did take a while for the penny to drop, actually, and even certainly in the UK, they put CO2 monitors in classrooms rather than just filter the air. Like, you know, then they knew what to do. They still didn't provide the kits. So it's not really rational to ignore the evidence in that way, you know.
I think what we've seen with some of the building regs is, you know, there's all the various parts. Each one is written with the focus to solve its specific problem, but it can, like particularly with air quality, it can generate other issues down the road with the level of oxygen, the level of airflow through, and then obviously with COVID we've seen it, that the aim was reducing the cost of heating that particular space. And I think, you know, Sue touched on it as well with,
yeah,
you know,
they're a funny animal. They're a funny animal, and Tom may be able to help this, but I have an understanding that the building regulations were generated in the first place by the insurance industry about the risk to building fabric and life. You know, so fire regulations are not to protect the building fabric in that case, but to make sure people can get out of a building that's on fire in time. And so now we have this awkward hybrid, you know, where other issues have been brought in on top. So it is a bit of a patchwork. But it will be interesting to go back to the insurance industry now and to sort of look at the actuarial risks of public health and, you know, like things, because they're very influential, but they're always just that little bit in the background, you know. Yeah. I mean, getting houses insured, if it's not standard construction, it's not straightforward. Mm-hmm. You know, they have a thing about non-conventional construction, and they have an idea of what is conventional construction, and you can't argue with them. Yeah, so that's quite a serious thing. I mean, steel frame or whatever, I don't know, you better ask those guys how do the insurers view it, because steel doesn't perform well in fire, you know, not at all.
We have our house insured and our Hempcrete house in the garden insured through one insurance company. And every year they write to us saying, please confirm that your house is built out of conventional brick construction. And we say, we've been writing to you for 20 years telling you that neither of our buildings are built out of conventional construction. In fact, the insurance companies haven't got a clue about building construction at all, and it's only when something burns down that they then turn up and say, oh well, you're not covered because we thought this was conventional construction. It's a serious problem. But one of the most disturbing figures I've come across recently is that firefighters are twice as likely to get cancer because they're exposed to the toxic materials which are emitted during fires. We're coming up to 5-year anniversary of Grenfell on June the 14th. Very important date. Everybody should be thinking about Grenfell on June the 14th, because one of the things about the Grenfell inquiry is it has exposed the way in which all these bodies, ranging from the building regulations, the BRE, the British Board of Agreement, all these different organisations have lied and cheated and faked for years and years. And if you've ever had a chance to view some of the Grenfell inquiry hearings, it is quite horrifying and the island sadly tends to just borrow a lot of its stuff from the crappy rubbish that's going on in Britain, which I just can't understand why they do that. Is it just laziness or what?
Sally, you?
Yeah, well, the second point about that is that the building control officers in Northern Ireland are something else. They are zen and the art of it. They're way better than the UK, I'd say. But in terms of just assiduousness and so on. But the Grenfell thing was a very good example. And I mean, I would probably, if it were constitutionally possible, ban smartphones from the building site, because trying to read documentation, never mind drawing, on a phone in daylight, the sun beating on, or in a sweaty old site hut, there's no way to look at documentation and check, does that comply? Because if you try reading through an agreement cert or something you do know, you try to find out what it's made of, it's on like page 8 or something. It's a very, very obscure way to work, and I think that carefulness is being completely lost. And people are literally scanning on iPhones or whatever through a drawing or a document and saying, sure, that'll do, in whatever dialect they speak in that particular job, because they can't see it, they don't read it, and they just want someone else to be responsible. So if someone says, and in that case they did, in fact, the building control officer on the project, wasn't apparently he wasn't asked to look at the cladding. The consultant, who was an ex building control officer, didn't study the cladding because apparently he wasn't asked to do it. So there's huge holes in the process there. So you really have to do your own homework.
Okay, thank you. I'm just keeping an eye on time there. Martina, we've probably run a little bit over with that discussion, but good to see. I suppose there's so many topics we're touching on. There's one request there with regards resources, and I know you'd said that a lot of the presenters will make those materials available, and I know a number of presenters mentioned that they've embedded links and they've lists of resources on their slides. So hopefully that'll be of use to people, so hopefully to go through further detail.
Compile them into an archive and we'll put them at a central point. Martina. Yeah.
Thank you.
Okay, thank you so much, Rita. We're just about 10 minutes over, so I think we should head into lunch.
Okay.
So at 12:30, the next panel will start.
At 1:30, okay.
Hopefully see you back. And thank you so much to all the speakers today. There's been such valuable materials, and I can see loads of more discussions and research coming out of this.
Yeah.
So
thank you very much.
Yeah.
It's great. Bye.